Hello, and welcome to another NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler, and today we're going to be doing Unit 1, Lesson 5, More Work Solving Two-Step Equations. I'm so inventive with the titles, right? And this is a follow-up to our last lesson where we reviewed the basic ideas and procedures for solving a two-step equation. Now, why are we doing a second day on it? Well, we're doing a second day on it because we want to now do some equations that get quite messy. And by that I mean some equations that involve fractions and also some equations that involve decimals. Now with the fraction work, we're going to do that mostly by hand. But the decimal work, we want to make sure we have our calculators available. My calculator is going to hang out down here for right now. Make sure that you have your calculator handy for when we get to that step. But let's first start off by doing some two-step equations that involve your favorite and mine, fractions. Let's do it. All right. Fractions everywhere. Let's take a look at exercise number 1. We saw some equations that had fractions involved in the previous lesson. Now let's work with some that have many fractions. Solve each of the following two-step equations. Express your answers in simplest form. Yay, right? Now let's take a look at letter A. Write together 2/3 times x plus 1/4 equals 5/2. Now this is no different than an equation like 2x plus 7 is equal to 13, right? The difference is what I'm multiplying x by is a fraction and what I'm adding on overall is a fraction. And yet the steps I'm going to go through are exactly the same. It's just that it's going to be a little more obnoxious. So let's tackle letter A together. All right, first thing I'm going to do is I'm going to subtract 1/4 from both sides. And immediately, of course, that becomes annoying because I have 5/2 minus 1/4. Now 5/2, if I get a common denominator, is 10/4. So 10/4 minus 1/4 will leave me with 9/4 on the right-hand side of this equation, and it'll leave me with 2/3 times x on the left-hand side. Now remember, instead of dividing both sides by 2/3, what we're going to do in this case is we're going to multiply both sides of the equation by 3/2. All right? That's going to allow us to cancel, giving us an x on this side. Now, if we could cross-cancel at this point, we would, but we really can't. We're just going to have 9 times 3 divided by 4 times 2, and that's going to be 27/8. If there's something in our problem that says that we should write improper fractions as mixed numbers, then we would want to change this to 3 and 3/8. But either one of these answers is actually acceptable at this point in time. All right. Remember, it's much easier to multiply both sides of an equation by the reciprocal of a fraction, canceling it out, than it is to divide both sides, even though it really gives you the same thing. Let's take a look at letter B together, because this one's a little bit weird. We've got 5 times c minus 7/3 is equal to 2. So here we've got a mix of both fractions and whole numbers. Keep in mind, of course, we could always write those whole numbers over the number 1 to turn them into fractions if we wanted to think about them that way. But let's solve this one together. Now, just like before, the first thing I'm going to do is I'm going to add a 7/3 to both sides. Now again, it's a little bit tricky here because what is 2 plus 7/3? Well, 2 can be thought of as the number 2 divided by 1. And if I want to get a common denominator, multiply both top and bottom by 3, and I'll get 6/3. So now I have 6/3 plus 7/3, which is going to give me 13/3 is equal to 5c. Now, again, we could certainly divide both sides of this equation by 5, but think about that for a minute. Then we'd have 13/3 divided by 5. And what exactly would that be? Well, it would actually be much easier in this problem, kind of to use the same trick we did before, and multiply this side by 1/5, because we definitely know how to multiply two fractions together. 1/5 and 5 cancel. And now we just multiply the top, 13 times 1, multiply the bottom, 3 times 5, and we find that c is equal to 13/15. All right, well, I left the best one for last. I left it for you. Why don't you go ahead and pause the video now and see if you can work through problem C. All right, let's go through it. Very similar to the last ones, what I want to start is by adding 1/2 to both sides. Again, I need to get a common denominator. Here I've got 5/6. Well, I can rewrite 1/2 as 3/6. So I'll have 5/6 plus 3/6, which will give me 8/6. And on this side, the left side, negative 4/3 times n. Now, what should I multiply both sides by? Well, I should multiply by negative 3/4. And we'll talk about why it should be negative and not positive in a moment. But let me just write it on both sides of the equation. All right. So just for a minute, let's talk about this. Because you might think, oh, well, I mean, I've got negative 4/3 over here. Maybe I should multiply by positive 3/4. Except I want to be left with a positive 1n on this side, a positive 1. So therefore, I must have negative times a negative. Okay? So the reciprocal, again, we're just going to multiply by the reciprocal of this fraction, which is still negative and happens to be negative 3/4. That's going to then cancel everything from this side. Now on this side, I have a positive times a negative, which is a negative. 4 will cancel into 8 2 times. 6 and 3 will cancel, giving me 1 and 2 here. So I'll get 2 times negative 1, watch out, don't lose that, which will be negative 2, divided by 2. And negative 2 divided by 2 is going to be negative 1. All right? Now again, it's easy to lose things like negatives. Here I have 8/6, which, by the way, think about that for a minute, reduces to 4/3. Right? Here I have negative 3/4. So 8/6 times negative 3/4 has to be a negative answer. Specifically, it's negative 2 divided by 2, which is negative 1. All right, fraction work with equation solving. It can get quite ugly. Just keep in mind what you know about fractions, common denominators, what you know about multiplying fractions, and what you know about positive and negative numbers. All right, let's keep moving on. Let's take a look at an applied problem involving a fraction. Exercise number 2. 2/3 of the students in a class go on a field trip over spring break. 2 chaperones joined the students on the trip. There were a total of 18 people on the trip. Let n be the number of total students in the class. Letter A asks us to write an equation involving n that models the situation. All right, well, think about this for a moment, and you have to make sure you understand this phrase, 2/3 of. 2/3 of implies we're going to be multiplying something by 2/3, right? Now, just for a moment, let's pretend the total number of kids in class were 9 kids. Just for a moment, let's just play around with this problem. So let's say there were 9 kids in the class. 2/3 then of the kids would be 2/3 times 9, and that would be 6, right? Because 1/3 of 9 is 3, so 2/3 of 9 would be 6. 6 plus those, how many chaperones? 2 chaperones would give us 8 total people. Clearly, there weren't 9 people in the class because 18 people went on the trip. Now, if n is the total number of people in the class, which it is, right, then what we want to think about is 2/3 of n, right? That's the number of kids that are actually going from the class on this trip. N is the total number of kids in the class. 2/3 times n gives us the total number of kids from the class that are going on the trip. But to those number of kids, we're going to add the 2 chaperones. Why? Because we know a total of 18 people went on the trip. So here's that equation that models this scenario. 2/3 of the total students plus 2 chaperones equals 18. Letter B asks us to solve the equation. Pause the video now and do that. All right, well, this is a snap compared to the other ones we've been doing. In fact, we'll just do the solution right here. I'm going to subtract 2 from both sides. That's going to give me 2/3 times n is equal to 16. Now I'm going to multiply both sides by 3/2. Cancel. If I want to think about it this way, the 2 goes into 16 8 times. 3 times 8 is 24. So the number of kids who go on this trip is 24. And that's pretty easy to check, right? We can think, oh, if I've got 24 kids in class, 2/3 of that, well, 1/3 of 24 is 8. 2/3 of 24 would be 16, right? Then 16 plus the additional 2 gives me the 18 total people that went on this trip. All right, great. Let's move on and now do some equation solving that involves decimals. Here we go. And for this, you really want your calculator. All right? And you want your calculator not because you can't add and subtract decimals, not because you can't multiply and divide decimals, but because, quite frankly, if that's what we were doing, we could probably get through just this one problem. All right? Keep in mind, though, decimals are numbers just like fractions, just like whole numbers, just like integers, right? But they're just messier to work with. So let's take a look at exercise 3. Solve each of the following two-step equations involving decimals. Do not round your final answers. All right, well, letter A, right, let's look at it together and then we'll go to the board. 2.9 times x plus 12.72 equals 27.8. All right, we want to solve that equation, two-step equation. We're going to end up subtracting 12.72 from both sides and then eventually dividing by 2.9. But we're going to let the calculator do a lot of that hard mechanical work, or at least lengthy mechanical work, without us having to spend all the time. So let's do it. Let's have our calculator handy. I'm going to subtract 12.72 from both sides of the equation. Let's do that really quick. First, I'm going to write down my 2.9x equals, and now again, this is why we have calculators. 27.8 minus 12.7. Come on, 7. Maybe if I move the calculator. 7.2. There we go, that worked. Gives me 15.08. Now I want to divide both sides by 2.9. That'll cancel. And let's break just for a moment, talk about this for a moment. Notice I want to take the last answer in my calculator, 15.08, and divide by 2.9. I could easily type in 15.08 divided by 2.9. But many calculators have what's called an answer function on them, where you can take the last answer you had and do something with it. For me, that button is right above the negative button on my calculator. So I'm literally going to go back to the screen now, and instead of typing in 15.08, I'm going to hit my second button and grab my answer, maybe. Let me try that again. Maybe I'm not going to do that. Nope, it just doesn't like it. There we go. No, now I just got my negative sign. Let me try it one more time. There we go. Come on. Oh, delete. Boy, it would have been just faster typing in the 15.08. Anyway, the answer divided by 2.9. Calculators. I think I'm never going to use that answer option again. 2.9, enter. There we go. Is equal to 5.2. Wow. Yeah, I'm going to stay away from that. 5.2. That may have taken just as long as if I did the decimal work by hand. Probably not. Hopefully we're going to get the calculator to work a little bit better in the future. I think I know what went wrong there, but we're going to give it a shot on the next one. Let's take a look at that one. Letter B. We have 0.08 times W minus 1.75 equals 8.13. So a little strategy. We're going to add 1.75 to both sides of the equation, and then we're going to end up dividing both sides by 0.08. And that's going to isolate the W. Let's try it again, hopefully this time with less calculator problems. All right, here we go. Plus 1.75 on both sides. All right, I'm going to clear this out, and I'm going to do 8.13 plus 1.75. Of course, it's working just fine now. right? And this is going to give me 0.08W is equal to 9.88. Now I'm not going to even try with that 9.88 in the answer key. I'm just going to divide both sides by 0.08. All right, that's going to cancel. And now let's see what I get. I'm going to clear this out really quick. I'm going to have 9.88 divided by 0.08. Enter. And W is 123.5. Whew, love it. All right. Maybe move that a little more out of the way so you can see. Right? And again, we're not doing anything different than what we did in the last exercise and what we did in that last lesson. Right? We're just solving a two-step equation. The difference is all the numbers are a little bit uglier because of the decimals. Let's look at letter C also together, because this brings out one of those problems that we saw in the last lesson where we've got the variable coming second in the expression. And therefore, it may be a little bit easier for me to flip-flop this thing and solve it before I actually do anything else. So let's jump right into letter C. All right. I'm going to rewrite this problem by bringing the negative 2.25t first plus 13.5 second. Gives me 4.95. That almost looks like a comma. Let me make the decimal a little bit bigger. All right, I'm going to bring my calculator over here. What I want to do first is I want to subtract a 13.5 from both sides. All right, and let's see what we get. On this side, we're going to be left with negative 2.25t. And on this side, let me clear this out. We're going to have 4.95 minus 13.5. Enter. Not surprisingly, we get a negative number. Negative 8.55. We're now going to divide both sides by negative 2.25. Cancel. And now let's do this. Let's clear this out. We're going to put negative 8.55. Make sure you're using the negative button and not the subtraction button. Negative 8.55 divided by negative 2.25 gives me t equals 3.8. Awesome. Let me move this out of the way. There we go. Right? Again, not all that difficult, right? We're just doing the same thing we've done before, but we use the calculator to help us with the decimals. All right? Let's do some more problems where we start to apply this. All right? Exercise number 4. Everybody likes a balloon. Okay? We've got a child releases a balloon from a height of 9.2 feet above the ground. It begins to rise at a steady rate of 3.8 feet per second. Let t be the time the balloon has been rising in seconds since it was let go. The first question simply asks, how high is the balloon above the ground after 10 seconds? So what I'd like you to do right now is pause the video and figure out how high the balloon is after 10 seconds, given the fact that it starts 9.2 feet above the ground and it's rising at 3.8 feet per second. Pause the video now. Just take a moment to do this. All right, this should be easy. Let's first figure out just how much the balloon rose. Well, it's rising 3.8 feet per second, look at that rate, times 10 seconds. So it's risen 3.8 times 10. I could use my calculator on this, but multiplication by 10 is so nice, right? So it's risen 38 feet, but now I need to take that 38 feet and I need to add to it the fact that it started at 9.2 feet. Again, I could use my calculator on that, but it's easy enough for me to do in my head. And we're at 47.2 feet. Now, the whole purpose of this problem is to just give you a sense for how you're going to end up setting up this equation in letter B. So let's take a look at letter B. Set up and solve an equation for the time t in seconds that it takes for the balloon to reach a height of 200 feet. Round to the nearest tenth of a second. Now, by the way, Notice in this case, the problem is telling us we're going to have to round our final answer, which means probably we're going to get some ugliness going on that the calculator is going to help us with, and ultimately we'll need to round. Now, how do we set up this equation? Well, we know, right, that we're going to have to take the amount of time and multiply it by 3.8, and then we're going to have to add 9.2 to it. And I want to know when that is equal to 200. So the equation I'm going to have is 3.8 times my amount of time plus 9.2 is equal to 200. To solve this, I'm going to subtract 9.2 from both sides. And again, why don't we now bring out our calculator for this? If you can do any of these things in your head, go ahead and do them. On the other hand, if you want to speed up your work some, you're going to simply use the calculator. So I'll have 3.8t is equal to 190.8. Bring the screen up a little bit. I'm going to divide both sides now by 3.8, always using that fraction bar to show division. So now, clear this out. I have 190.8 divided by 3.8, enter, and I get 50.210, etc. Right, nice messy answer there. They want me to round to the nearest tenth of a second, so that's 50.2 seconds. All right. Modeling our problem, right? 3.8 times t plus 9.2 is equal to 200, and then solving it the way that we would solve any other two-step equation. Let's do some more of these modeling problems. Let's see what we have. Exercise number 5, let me move our calculator back out of the way. Let's read it together. Maria used a $20 bill to pay for gasoline that cost $2.78 per gallon. She received $4.71 back in change. Let G be equal to the number of gallons of gasoline that Maria bought. The equation shown below models this scenario. So in other words, we're given the equation. 20 minus 2.78 times G equals 4.71. Letter A simply asks us to explain what the two terms of the binomial 20 minus 2.78G represent. Think about this a little bit. What do the two portions or the two terms of this binomial represent? I bet this is pretty easy, but pause the video now and think about this. All right, well, if you look at the context of the problem, right, the 20 is the original amount of money. Right? She starts with $20. Now the 2.78 times G is how much she spends on gas. And let's talk about that a little bit, right? If we take the cost per gallon of gas, which is $2.78, and we multiply it by the number of gallons of gasoline that we bought, then that will tell us how much she spent on gas. So if I take the original amount of money, subtract off how much she spends on gas, I get how much change she got. Letter B asks us to solve the equation for G. Pause the video now and try to do that. All right, well, this is one of those great equations where I think I'm going to flip-flop the order of the subtraction over here by making it into addition by a negative, just to help me think about this problem a little bit more. I'll bring up my calculator up to here, and I'm going to rewrite this as negative 2.78G plus 20 is equal to 4.71. I'm going to subtract a 20 from both sides, and again, I think this is a great time for the calculator. Right, we've got 4.71 minus 20. This is going to be a negative number, right? We expect that because 20 is larger. So I have negative 2.78g equals negative 15.29. I'm now going to divide both sides by negative 2.78. That'll cancel. Over here, I'm going to clear out my calculator. I'm going to put in negative 15.29 divided by negative 2.78. Enter. And it looks like she got 5.5 gallons of gas. All right. Kind of a nice problem because it forces us to flip-flop that order and then deal with some negatives. All right, let's do one more problem. Let's bring this thing down. Exercise number 6. This is going to be a challenging one, but it's a good review of some basic ideas about percent. Exercise number 6. Carmen moved 35% of the total amount A that she had in checking to her savings account. So maybe she had too much money in checkings, so she moved 35% of it over to savings. Before she moved the money, her savings account had $472.25. After she moved the money, it contained $1,259.75. Find out the amount of money A she originally had in her checking account. Well, let's review something very basic. Let's just say that she originally had, I don't know, let's say that she had $600 in her checking account. I really hope that's not the final answer, right? How would we find 35% of that, right? 35% of this number. Well, remember, we do that, we find a percent using a multiplication problem by doing 0.35 times 600. And in fact, right, if we did that on our calculator, 0.35 times 600, right? That would give us $210. Nope, that wasn't it, right? But that's okay. I didn't really want it to be it. What I wanted to review was how we find 35% of the total amount. Now, I don't want 600 in here. I want A, because that's what I don't know, right? So my model is going to be the following. 0.35 times A. Right? That's the amount of money that she moved over, plus how much she had there to begin with, $472.25. All of that, bye-bye calculator, is going to be $1,259.75. So decimals everywhere. I can now solve this by subtracting the $472.25 from both sides. Those will cancel. Here comes that calculator work, right? I'm going to have, hopefully, 1,259.75 minus 472.25. And that leaves me with 0.35A equals 787.5. I can now solve for A by simply dividing both sides by 0.35. That's going to cancel. And the amount of money we had there to begin with was what? 787.5 divided by 0.35. Enter. $2,250. Right? So a little modeling problem involving percent. Remember, whenever you want to find the percent of a total, you simply have the decimal version of that percent, which you can find by dividing the percent by 100. So 35 divided by 100 is 0.35. 0.35 times that total amount plus that is equal to what we had at the end, and that allows us to find that total amount. All right, let's wrap this up. Bye-bye calculator. From the perspective of solving equations, we did nothing new today. All we did was solve more two-step equations. Yet, the two-step equations we were solving got messy. You know, they had fractions in them, they had decimals in them, The fractional equations we tried to do all by hand, right? On the other hand, the decimal equations, we brought that calculator in to help us do some of the division, the addition, subtraction, etc. All right? Get practice on these types of equations, these messy two-step equations, at home on the homework, right? Because we're going to need them next time when we start solving equations with variables on both sides of the equal sign. For now, I want to thank you for joining me for another NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.